Okay, good morning everyone. So in the last class we were looking at arrays. We looked at integer arrays which are equivalent to the way integer arrays work, floats, double, all of them work in the same way. But character arrays are slightly different. They are quite similar to other kinds of arrays, but there are some additional functions which are available with character arrays or strings because we use them many times, right? So we looked at different ways of initializing a string, right? So you can initialize a string similar to an integer array. You first tell the data type, the array name, the size, and then the content of that array. Now, since this is a string, you can combine all the elements of the array into a string and put it in double quotes. All right. Or you can also specify elements separately as individual elements or individual characters. But one important thing which you need to remember in strings is they always end with /0, \0. Okay. So that is used to identify the ending of the string. So strings are not identified just by based on the length of the array. In fact, even length of the array is calculated in terms of the position of the null character. Whatever we call as \0, that is null character. Okay. So these are different methods of initializing a string. These are also some methods. So here the size of the string, the size of the character array is much larger than the string which it is holding. So the remaining elements will be initiated to /0. So you can either declare it as a single string in double quotes, or you can declare it as individual elements in set format. Okay, so anyway you can declare, the remaining characters will be initialized to /0. So when you are giving it in the form of a string in double quotes, you need not worry about \0. It will automatically insert \0. But if you are giving as individual elements, then you need to ensure that you give \0 also as an element. Okay, and the string size should be minimally n+1, where n is the number of characters in the string. The array size should be minimally n+1 to hold the null character. Fine. Okay, you can't assign a string to a variable, an array variable like this, like a equal to hello, like that. You cannot assign like that. The only exception is only during initialization you can do something like that, char a equal to hello. Only there you can do that. But if you separate initialization, declaration and initialization, you cannot do this. During declaration itself, you can initialize in the same line. Or if you are doing in a separate line, you have to do like this. You declare and then you initialize like this. You cannot write a equal to hello like this. All right, this will not work in C. If you want to copy the string hello into A, you have to use some function called string copy. We'll look at some of these functions today. Okay, so I gave these code snippets. I uploaded them on Euclid along with these lecture slides, but let's just quickly try some of them. So what is this saying? This is saying this is not giving size of A. So the size of A is inferred from number of elements given in this set. Okay. So actually how many how many elements are there here? 8. Okay. So actually size of A will be 8. But when you try to print as %s A, what will it look for? It will not look for 8 characters. It doesn't know the size. It only looks for null character. So what does it print? Hello. That's all. Okay. So it stops at null character. Whatever is there after that, it will ignore that. And this one here, the size of the array is smaller than the string which it is holding. This we saw earlier. It will stop at HEL. Okay, 3 characters. It will stop at 3 characters. After that, it will insert /0. But technically, that /0 is outside the array, which is not a good thing. Okay, so ensure your array size is at least n+1. The string which you are holding, it should be 1 more than the number of characters in the string. And so here also, so in the previous case and this case, what is the difference? In the previous case, we defined the string in the code itself. In the next case, we were giving the input string from the terminal. So let's say now here we have a choice of giving different length strings. Here I can give a 3-letter string, 2-letter string, 5-letter string, 100-letter string. I can give anything I want. So let's give first 2-letter string, something like hi. It takes that. 3-letter string, something like hey. It will take that also. If I give a long string, you see, it suddenly aborts, saying whatever stack smashing detected, because it is overflowing the array size. Now you may think, okay, it is anyway printing the string, but if only you have any other lines after this line, after this print line, suppose if I just say print, I am printing this line also. If I want to print this, it can't print because it will stop in the previous line. In the previous line, it encountered an error, so it will abort there itself. So it will not print this last line. Okay. So whatever long string I give, you see, it aborted. It sort of stopped at that line only. It is unable to print the next line. Fine. So it's not a good habit to give much larger strings than what the array can hold. And here, again, the array size is 3, but you're trying to store a string with 5 characters. Now we want to print until we see \0. Okay. So here what happens, the array size is 3. So it actually takes 3 characters and then immediately inserts \0. So it will print 3 characters only. It will not print all the 5 characters. Okay. So let's check this. Just warning that the string size is larger. You see, it's printing only 3 characters, which means the 4th character is null character. All right. It is automatically inserting that, but it is inserting outside the array. Array is only these 3 characters. Okay, which is not a good thing. So these kind of things may work sometimes, may not work sometimes. So always ensure you have an additional space for the null character. Next one, same thing, but in the previous case we printed %C. Now in the next code we are printing their decimal values. Okay, so it will just print the same thing with decimal values of HEL. So I won't run it. Now in this case we are printing the first 20 characters. Okay, so let's see. You see, it stopped at HEL. 4th character is null character. After that, there are some random characters, we don't know what. Fine. So some are null characters, some are unprintable characters, some are some numbers which cannot be mapped to characters. So it tried to convert those numbers into some characters, but those characters are unprintable. So it is printing something. All right. So this is like we are trying to access out of bounds, out of the array bounds. All right. So this is some, what do we say? These are some limitations of C, in the sense it is allowing you to access the memory which you don't have access to, which is not a good thing from security point of view. All right. So people can use this loophole to hack into the system. Okay. So these things are there. So we have later programming like Java ensures that the user cannot do such things. So it does not allow you to access array out of bounds, right? So some programming languages build in security features. So the disadvantage there is it will be a little slower because it has to check every time whether you are within the bounds of the array or outside the bounds of the array. Programming languages like C and C++ are faster because they don't worry about these things. Okay, these are normally, these don't matter, but if you want to build a high security system, then you need to take care of these kind of things. Okay, so each language has its own advantages and disadvantages. Python is more user friendly to read, but it is slower compared to C, C++, Java, etc. Java is more secure, but again it is slow compared to C, C++. C, C++ are the fastest languages, but they have these security issues. Okay, and also they are not as user friendly to read as Python or other scripting languages. So each language has its own specific purpose. Although every language is technically more or less equally powerful, but convenience wise, some languages are more convenient in some sense. Okay, that's the only difference why we choose one particular language over other. Here again, same thing. In the previous case, we were printing percentage %C. Now we will be printing percentage %B, but all the 20 places. So it will print HEL and then some random values. Now it will print integers. It will not print characters. It will not print these unprintable characters. It will directly print whatever integers are present in those cells. You see? So most of them are zeros. So it is printing them. But here, okay, here I gave char A20 equal to hello. So then it's not actually the previous one and this one are different. It is char A3 equal to hello. This is char AF20 equal to hello. So both are different. So here there is sufficient space. It will allocate first 5 elements, first 5 places to hello, and then fill all the remaining with zeros. Okay, so there is no issue here. So that's the output you got. Same thing here. It will print. It will fill first 5 spaces with hello and 6th space with null character. But null character's ASCII value is also 0. So technically, all the remaining places it will fill with null character. Null character or ASCII value 0 both are same. Okay. So when you are trying to print a string, it will traverse up to the first null character, and it will print the number of letters up to that point. Okay. So let's just quickly try this as well. Same thing. Okay. All right. So this code, okay, first let me copy this. So you see now, here we declared an array of size 20, and here we gave 20 characters like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. These are 10 digits, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 digits, 19 digits, and 1 digit for null character. So 20 digits, 20 characters. So here each digit is a character, not a number. This is a string. This is not a number because it is put in double quotes. Okay. So here 19 characters plus null character, 20 characters, sufficient. Now we ask the user to enter a string less than 20 characters, and we store it again in the same string, user string. Now what will happen? The first, suppose if I enter a string of length 5, suppose I enter hello. Okay. So what will happen? The first 5 characters are replaced with hello, and the 6th character will be replaced with null character. So first 6, 1, 2, 3, 4, 5, 6 are replaced with hello and null, and then the remaining will be present as they are 7, 8, 9, 0, and so on. Okay. Now this is just checking for in case you gave a string which has some at symbol. I say hello at everyone, something like that, hello at all. In that case, it will say I found at. Actually, this is sort of optional. So let me just print a character. Okay, so it will print hello and it will stop there. But so here, what are we looking for? Here we are looking for the first null character. Fine. So suppose if I input a string hello, it will store hello in the first 5 places and immediately store null character. Now in this loop, we are checking for up to null character you print. So it will print only hello. Although after null character, there are the old characters. It will not print them. So let me just show it to you first. Did I miss? So some strings, suppose I entered hello. You see it printed only up to that. Actually, first let me print the original string. Okay, so original string is this. Now I am entering hello. After entering hello, what did I write? You loop from the first character up to the null character and print those characters. Okay, so it prints only up to hello. All right. Now, rather than stopping at the null character, I will say print the first 20 characters. Okay, so print all the 20 characters. So what will it do? It will print hello, then null character. So 6 characters are gone. In the previous string, first 6 digits are gone. Then 7, 8, 9, those are remaining. Those it will print now. Okay, so this, let me. Okay. Now you see, first loop was stopping at null character. Next loop is printing all 20 characters. Now what happened? Hello, 5 characters are over, and then 6 is also not printed because that went for null character. And remaining are as they are, 7, 8, 9, 0, 1, 2, 3, 4, and so on. Okay. So earlier 20 characters were filled with 1, 2, 3, 4, and so on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. 19 characters were filled. Last character was null character. Now you scanned hello and stored it in the string. The first 5 characters hello, 6th character is null character. The remaining characters were as they are. Okay, so now it's up to you. If you say percentages, it will just print up to the first null character, so it will just print hello. Or if you write a separate for loop, if you stop at first null character, even then it will again print only a hello. But if you choose to traverse using number, okay, print the first 20 places, not the null character. It will print all the characters. Null character is invisible, so it will not print it. Okay, got it? Now, last thing. Now, suppose we try to print more than 20. Okay. Now, what will happen? It will print some arbitrary values. It is going beyond the bounds of the array, right? So it will print some arbitrary value. So it's saying the following is an even worse error. Access is beyond valid index range. Program may crash. Fine. In this case, where we are going like we are not stopping at null character, we are going up to the 20th character. The following is an error. May print characters it shouldn't. It doesn't stop at null character because you are asking deliberately to go up to the 20th character. But it doesn't make sense because it's like 2 different strings are stored in the same array, right? One null character, before that one string, after null character, another string. Okay, so it is not it will not work in an expected way. That's the only difference. But in the third case, where you are printing all going beyond 20, printing up to 30 characters, it will print some unprintable characters as well. Yeah, you see here. So after 9, it is printing some unprintable characters. Some numbers are there. We don't know what they are. So let's try to print %d. Okay, instead of %c, in a new line, we will print %d in a new line. You see here. So this is hello. Okay, HELLO, and then null character 0, and then 1, 2, 3, 4, 5. 7, 8, 9. Those characters are there. 9. After that again null character 0. After that outside the array. All these are outside the array. So these numbers it was trying to convert to character. -1 has no character associated with it. Negative numbers have no character associated with them. So it is trying to convert it into character, but it will convert to maybe 255 or something. And then that 255 is associated to ASCII. That value it is trying to print. But those are unprintable characters. Okay. So that's how it's trying to work out. Fine. Okay, so this is done. All right. So far we have seen percentages. We were scanning a string using percentages. Now, suppose if I give a string with spaces, when I do scanf percentages, let's see what happens. So let me remove all this. So I initialize something. Okay, let me even remove this. Okay, so I am giving a string. It just should print that. That's okay. I didn't use a variable. That's fine. So suppose I just give hello, it prints hello. Now, now if I say hello world, what will it print? Huh? It will print only hello. It will not take world because it will stop at space. Okay? It will read, when you say percentages, it will read up to the characters until it finds a white space. It can be a space, a tab, or a new line. Okay? So after that, whatever is there, it will ignore. But suppose I want to read that entire string, including spaces, right? I may write a new line. I'm a good boy, something like that. I want to read that entire line. Now what do? I can't write percentages, and I also don't know exactly how many characters I will get. I may know the maximum number of characters I may get. Fine. So in those cases, there are, okay, sorry. Yeah. So in that case, let's first look at the last line. I will come back to the previous ones. To scan the entire string with spaces until the new line, we need to use either of the following. There is a command, there is a function called gets input. This is deprecated and dangerous, so strongly suggested not to use it. This function will work, but don't use it. It has some side effects. Okay. There is another function called fgets. So fgets has three parameters. One is your array name. In which array do you want to store the string? Second, what is the maximum length of this input string? Like you can store maximum 50 characters. So your input array can be anything less than 50. It can be 10, 20, 30, 49, whatever it is. Fine. It can be max 50 or it can be max 100. So you specify that number here, length. std in is the place from where it is expecting the input, standard input. So the terminal through which we are giving the input, that is called std in. And in case when you write printf statement, wherever it prints it, that is on the terminal again, right? So in that case, that is called std out, standard output. All right. If you are using some file name, you want to read from a file or write into a file, then you will give that file name in place of std in. We will see if we get time to handle file pointers. But otherwise, std in and std out are also like files. It is reading from std in file or it is writing to std out file. Okay, so fgets is one way in which you can read a string including spaces up to the new line, and you can store it in a particular array variable called input, and you can specify the maximum string length, whatever number it is. It can be 50, 100,000, whatever it is. It will read so many characters. In case your new line comes in between, it will stop there. Okay, whatever is there in the next line, it will ignore, and then it reads from standard input. Fine. The third option is scanf, this complex format specifier. So this is like a regular expression. So what it says is read all characters up to not including new line. This caret symbol means exclude new line and read all characters percentage star c. So don't worry if you don't understand, just remember it. This will work, this will do the job. So now let's use these both methods, fgets and scanf. Huh? Yes, spaces will also be counted as a character. Okay, so now instead of scanf, I will give fgets. What is my array name? User string, and maximum length, say 20 characters, and I am taking the input from std in. All right. Now, even if I give a string with spaces, it should take that entire string. So I say hello world. Now it will take entire hello world because it is within 20 characters. See, it took entire hello world. Now suppose I give a string larger than 20. Something. Okay. Now it stopped before that. It cut at 20. So it takes sort of 19 characters and it inserts null character at the end automatically. Okay. If it encounters new line before the 20 characters, before 19 characters, it will include new line also and then insert null character. Fine. So you need to read a bit about these things. Everything, every detail I can't get into. Minimally, I introduced you to this function. You need to read about this function on your own. Fine. And then scanf example also we'll see. So percentage bracket caret backslash n, close the bracket, percentage star c, string name. Okay. See, even in this case, it took the entire string, including spaces. Fine. Anything you can use. Okay. All right. So these are some points which we saw already. When we use percentages in scanf to take the input from a user, it scans only until the first word. It does not scan multiple words at once. For instance, if the user input is hello world, then scanf percentages will scan only the word hello and ignore the second word world. Notice that there is no ampersand before the array variable input, right? So if you see here, there is no ampersand. We are not writing ampersand user string. We are just writing user string. Okay. But if you are scanning a character and you want to store it in user string 0, then you should write ampersand user string 0, right? If you are giving an entire array name, do not put ampersand. If you are giving an element index, then put ampersand. You will understand this later when we get into pointers. Fine. So notice that there is no ampersand variable ampersand before the array variable input while scanning, because the array variable is like a pointer to a character. Which character? The first character of the array, and hence an address already. Okay. Why do we give ampersand? I said ampersand means address. Address or the location. If you are scanning a particular integer or a float or a character, you should tell the compiler where to store it, which means you should give the address where to store it. That is why you put ampersand x, ampersand y, whatever it is. But if you are giving an array name itself is an address. Array name itself is pointing to the first element of the array. So you need not again put ampersand before that. That will be like address of address. Don't need to do that. Okay. So array name, since it's already an address, it already knows where to store the input, where to begin the input from. So you just give the array name if it is an array name. Fine. Yeah. So no need to precede it with a ampersand symbol. All right. So this we just saw. If you want to scan entire string up to a new line, you use one of these three methods. Preferably don't use the first method. Use the second or third method. Okay. Fine. So before we look at some string functions, let's look at some character functions. These are they just come handy. You can do without these functions as well, but they will just make your job slightly easier. Fine. So if you want to use these functions, you should include a library called ctype.h to use any of the below functions. So what do these functions do? Is lower takes a character and checks whether that character is in lowercase or not. If yes, it will return 1, otherwise it will return 0. Is upper, it will return 1 if the character is in uppercase. Is alpha, it will return 1 if the character is an alphabet. Is digit will return 1 if the character is a digit, 1, 2, 3, 4, 9 up to 0 to 9. Is punct, is all num will return 1 if the character is either an alphabet or a number. Is punct will return 1 if the character is some punctuation mark, some non-alphabetic numeric symbol. Okay. Is space will return if the character is either space or tab or new line. To upper will convert a lowercase character to an uppercase character. If it is already uppercase, it will just keep it as it is. Or if it is not a character at all, it will leave it as it is. If it is either a digit or some punctuation symbol, it will leave it as it is. Similarly, to lower will convert uppercase to lowercase. If it is already lowercase or some other symbol, it will return the same character. So let's look at a couple of functions. All right. So suppose I say cat ch. Now I say ch. There is another function called getChar. So if you just want to scan a character and just store it, so rather than using scanf, %c, %ch, all these things, you can just say getChar. That getChar will take the character and put it in ch. Okay, so this is the same as scanf %c %ch. Okay, same thing. Now what do I want to do? If is lower ch, okay, printf yes, else printf no. Let's print a new line after this. We need to include ctype.h library to use these functions. All right. So let's give a character. I give small h, it says yes. Suppose I give capital H, it says no, right? I give some number, it says no, right? That's it. So this is like checking if ch is between, if ch ASCII value is between 65 and 96, something like that. Print yes. No. 97, the small letters start from 97. So 97 and whatever, 125 or something. Print yes. Otherwise print no. So you can also write this, but this function will just make it easier. Okay. Similarly, is upper, is digit, is num, is alpha num, all those will work. Okay. So let's look at 2 upper and 2 lower. So now what I do? So here it is not about returning true or false. It is about actually performing an action. You give a character, you change it to uppercase or lowercase. Okay. So it will not return true or false. It will return the character itself, uppercase character or lowercase character. So what I will do, print %c to upper th. So what I will do, I can also write like this. Suppose if p is lower ch, okay, you convert it to its uppercase and print it. Fine. So this I'll remove for now. Okay. So let's see. Let me print a new line. You see, it converted small h to capital H and printed it. Fine. That's all. Similarly, to lower, whatever it is. So these functions are there. Okay. So you can, in case you want to read more about them, I gave a link. You can go to that. Fine. All right. Now let's look at. So this is clear. Any doubts? Quite simple. Except the last two, all the previous functions are like true false functions. They return true or false depending on the input. The last two, they change the character and give you. They return a character itself. Fine, simple. So now let's look at some string library functions. To use them, you should include string.h library. Okay. So in case you want to copy one string to another string, you have a function called string copy. Suppose you want to copy only first n characters from one string to another string, then you have the second function string n copy. Suppose you want to concatenate two strings, then you have a function called string cat. If you want to concatenate only n characters of one string to the other string, you have string n cat. If you want to find or look for a character, search for a character in a string, you have strchr function. If you want to find the length of a string, you have string length function. If you want to compare whether two strings are same or not, you have string compare function. Okay. So there are many other functions. I gave you a link. This link will speak of some other functions, but these are minimally very important and more frequently used functions. Okay. So let's just test some of them. So suppose I say cat source 20 equal to, suppose I won't say anything, source 20, yeah, here I will say hello, and I will say destination, some 20 characters. I will not declare destination. Now I want to copy hello from source to destination. Okay. I cannot never do this destination equal to source. This will not work. This will not give you error, but this will not work. Again, you will understand when we get into pointers. So this will not work. Okay. So actually this will also give you error, because an array name cannot be used on the left hand side. An array is given a fixed value the moment you declare it. You cannot change its value. When you get into pointers, you will understand you can have a separate pointer pointing to the same location as the array, and you can change that pointer. But array is pointing to an address. Okay, so that address you cannot change. You cannot use this array name to point to a different address. No, this address is fixed. All right. So array is like a static variable, const variable. You cannot change it. So you cannot use it on the left hand side. All right. So suppose if I do this, it will actually give an error. See, it gave an error. Assignment to expression with array type. You cannot assign anything to a variable which is of array type. Okay. Whatever is on the right hand side doesn't matter. You cannot put the array name on the left hand side. So if I want to copy, what will I do? You see, again in copy, you need to keep in mind it is slightly counterintuitive. You first don't write source and then destination. You should first write destination array name and then source array name. So it should look like destination source. Okay. Now first let me print source array is. So after copying, I can print destination array is. Okay, fine. String.h. Yeah. So they just copied. It just copied into destination array. Okay. Another way is, suppose you want to declare. Suppose you don't initialize anything when you're declaring the array. Now I want to copy some value into my source. So I'll copy this string into my source. So this is another way of initializing your array, right? Because once declaration is done, now you cannot say source equal to hello. Again, why? Source is an array name that cannot go in the left hand side. If you want to copy something into the source, you have to use this. Okay. So now there is no need of destination array. Okay. This works. But if I say source equal to hello, it won't work. It will give an error. See, you cannot assign anything to array name. Fine. So if you want to copy something, you have to use this string copy function. You cannot use this line, source equal to hello. Fine. So this is string copy. Now again, you need to check for all possible cases. What if the destination string is smaller than the source string? What if the destination string is equal to the length of the source string? What if the destination string is larger than the length of the source string? So again, go to this website, look up these different cases, and you just understand. Okay, every case I can't cover. And string and copy. So copy only some n digits from the destination to source. Suppose I want to copy only 3 letters. All right. So in this, I write string. Okay, I will change this. In this itself, I can do string and copy. From hello, I want to copy only 3 letters into src. So now source array will have only HEL. Okay. Okay. What is it doing? Yeah, this problem is coming when I say percentages, it is printing something after HEL, right? This problem is coming because in string copy, string n copy, what happens is it copies the 3 characters, but it does not insert null character after that. So you need to insert the null character immediately after copying the 3 characters. All right. But in string copy, the entire string, when it is copying, it copies the string along with the null character if there is space. If there is no space, it anyway cannot copy. If there is space, it will copy the string along with the null character. So there is a difference between string copy and string n copy. In string copy, it will copy with the null character. In string n copy, it will not copy the null character. You have to insert the null character. Okay, that is what is happening. So it is going up to the null character. It is not finding null character immediately after HEL. It is finding it after some places. So it is printing up to that. Okay, we don't know how many places it will find. In this case, it found 3 more characters after HEL, but in some other cases, it can go up to 100 characters. We don't know. So you ensure that after you copy 3 characters, you put a null character. Fine. Again, you will understand when you read the function details. Okay. String cat, it is concatenation. So suppose I say this is space world, this is hello. Okay, now I say string cat which means I concatenate my source string to my destination string and update my destination string. Okay, so now what will my destination array be? Hello world. This space world will be appended to hello. Okay. Okay. Destination array is hello world. Fine. Yeah. Similarly, n characters will be concatenated in if you use the next function string n cat and string chr. So you are looking for a character. So if there is more than one occurrence of that character, it will give the first occurrence index of that character. Okay. So let's see. So I will not concatenate anything. So what I will do, printf the index of L in destination array is, it is some index. It's like, so what is the index of first L in hello? Position. Index is position starting from 0, 2. Okay, so it should print 2. str chr what do we say? I don't remember the order, whether it's array name and character or character or array name. Let's see. Yeah, I think no. Okay, let's just check. Okay. Just a minute. Finds out the first occurrence of a given character in a string. Yes. So what is the problem? Okay. Percentages. Why is it giving percentages? Okay. From there, it is printing the entire remaining string. So it is giving the position of the first letter, but it is giving the not just the number, but the pointer to that letter. Again, you will understand when you look at pointers. So the first L occurs in index 2. Okay, so from there, whatever is the rest of the string, it will print that. So LLO, it will print that in the output. Okay, so let's see that. So not index. So the rest of the string from the first L in destination array is %s. Okay, so it will print LLO. Yeah, okay, fine. So whatever letter you take, if you look for letter H, it will print from there remaining. If you look for letter E, it will print ELLO. If you look for letter L, it will print LLO. Okay. There is also another function, string reverse char. So that will look for the last occurrence of that character from the right. So that is also mentioned in this page itself. I didn't mention it in the slide, but it is mentioned here. So string reverse char. You see, it finds out the last occurrence of a given character in a string. Okay, so you'll find some more functions than what I mentioned in the slides. All right, and string length. So string length will count the number of characters in the string excluding the null character. So when I say hello, there are 5 characters and the null character, it will ignore the null character, it will say 5. Okay, so here I can say it is length. So string length source. What should the answer be? 5. What is source? Space is also there, no? So 6. 6. Okay. Fine. String compare. This is important. So when you compare two strings, suppose now string source has some value, destination has some value. Now I want to know whether these two strings are same or not. Now, it will give some number. Okay. So let's see what it will give. It is giving some number, minus or plus, whatever it is. Now, if you want to know whether two strings are same or not, if string compare function returns 0, then two strings are same, which means there is no difference between the two strings. Okay. If it returns anything other than 0, it means they are different. So it is again counterintuitive. If string compare source and destination equal to 0, then they are equal. Otherwise, they are not equal. If it is anything other than 0, they are not equal. Like in this case, they are not equal. So you got some non-zero number. It can be negative, positive. Negative means first string is greater than second string. It's like it will try to order them in dictionary order. If first string, it will go character by character. If first string has a character which is of a greater value than the next string, it will give negative value. Right? I'm not sure if it is first is greater or lesser. You just check the documentation. But the important thing is, if they are equal, the output will be 0. If the output is not 0, they're not equal. Okay. So always remember this. So don't write if string compare source destination print they are equal. No. If not string compare source destination, then they are equal. Okay. Fine. Okay. Quickly, let's look at 2D arrays. So 2D arrays, this is like matrix, right? We all know matrices, rows and columns. So matrices are nothing but 2D arrays. We have 2D matrix, then we can have higher dimensional matrices also, 3D, 4D, ND, whatever they are. But we'll just limit to 2D arrays in this course. So it's like this. It is initialized like this: data type, array name, and number of rows, number of columns. Okay, and you can initialize like this, or you can initialize it in multiple lines. Okay, first row, these elements are there. Second row, these elements are there. Fine, that's it. Now you can write 2 for loops to traverse through the matrix. So first outer for loop will be number of rows. I goes from 1 to number of rows, or 0 to number of rows minus 1. j goes from 0 to number of columns minus 1. Print a of I comma j. A, not comma, a of ij. Okay, you should write like this: 2 and 3 separately. You don't write 2 comma 3. That will give an error. Okay, and then this array is technically stored. This 2D array is technically stored as a 1D array in the RAM, because RAM everything is linear. Okay, so this particular way. So how are we doing it? First we are going row by row. First row is stored, then second row is stored, then third row is stored. So this is called row major order. You can store in another way also, column major order. First column you store, then second column, then third column. That is column major order. We will not worry about that right now. Let's just think of row major order. Okay, a 2D array is converted to 1D array. So if you look at the addresses, how will they look? Suppose this address is 200, this address is 204, this is 208, then this will be 212, 216, 220, then this will be 224, 228, 232, right? So addresses will go on like that. So they are stored next to each other. Fine. Okay. And then 2D character arrays, very similar. The only difference is, rather than giving element by element, you can put the entire row in string format and give it as an element. Give it as an element in the declaration, initialization. Like you see, suppose there is a array of books, number of books, and the title of each book, the length of the max length of the title of a book. Okay, so what this is saying here, there are 2 books, each book title length can be max 30 characters. And then I am mentioning 2 books, something, White Tiger and Sherlock Holmes. So this thing is actually a row. The White Tiger is a row of characters. I could as well write this as a set where THE space white WHITE, that I can write it like that, or I can just write it as a string. It will automatically convert it into an array of characters. Fine. This is another way of declaring a 2D string array, or you can also declare it like this. Like I mentioned earlier, you initialize, you declare separately and then initialize like this. Okay, first row is the White Tiger, second row is Sherlock Holmes. You copy this string into books 0. You copy Sherlock Holmes string into books 1. Okay, so this is 2D arrays, strings, arrays, character functions, string functions. Arrays and strings are done. Okay, you need to go back and look up the resources which I mentioned for you to understand these things better. Everything, we can't get into every detail. Fine. Okay, so let me take the attendance.